Welcome, everyone. I'm Thomas Gunkel from Skyline Communications. For those who don't know the company, probably know our solution we offer in the market, which is Data Miner. I just learned it's the very last demonstration for the show or presentation. Let me talk about the dynamic media facility today. More about the resource planning and orchestration. Just a very brief one. Where do we stand today? It's pretty simple. What is the challenge to solve? We have more content than ever, but not more people than ever, and not more screen time than ever. So that reaches a bit of a maximum, which means we need to be more efficient because there is less revenue per media asset, and the industry needs to become more efficient. We need to do more with less and do it also fast nowadays. At the same time, we want to achieve flexibility. What is it? You heard it in the last presentation. We want to handle different productions at different time of the day. We need the flexibility to briefly or quickly switch. At the same time, it's about costs. You only want to pay for infrastructure when you use them in the media services. And that goes along with increasing what we also heard from Imagine, the resource utilization, how they call it, and optimize the costs. When we talk about dynamic media infrastructure, on the left-hand side of that slide, you see what is the main topic. It's MXL, that media exchange layer. We have companies out there presenting solutions, but also, and I want to bring this to the table here, don't think only about software and Kubernetes and cloud-based. There can also be dynamics in FPGA-based platforms, just by the fact that you reprogram those based on the needs you have in the future. That can add some dynamics to your media facility. That can also save costs already, where you can add those personalities on demand. When we talk about dynamic media infrastructure, I always talk about a life cycle. When you think of how you manage infrastructure along with your events, with your productions, there is a start. You need to design it. You need to define what you need. Then you need to plan for those resources up front. You need to provision those, automate it. You need to configure those. So provisioning means spinning them up. Configuration, applying the right parameters to it. You need to connect it. You need to operate it. This is what you do today. We have always on. And then most important, there's that finalization process when you need to undeploy and decommission things again. And during that whole process, everything needs to be monitored. So what does it mean? You need to plan ahead of time. This is most important. Something like manual resource management, when you do this manually with spreadsheets and pencils, will also not work anymore. So you need to automate and orchestrate. And most important, everything needs to be monitored along the way. One slide here, I wanted to bring this up as well. People use the word orchestration in many different ways. The way we use it here gives it a bit of a different angle. When we talk about control, this is really about regulating things or controlling things in real time. You have controllers, you execute as fast as possible. Automation, one step ahead. It's execution of things you could do manually, but mostly you use then automation to trigger this at a specific time or based on a certain trigger, maybe on an alarm or on a schedule. And orchestration, the way we use it here, is much more aligned with scheduling. Here we call it a framework to automate life cycles of an event, of your service, of your production, and to enter across multiple technology domains. There's always multiple vendors involved. And most important here, you need to manage resources. And resources, in a sense that you need to keep in mind, and I will talk about this later in more detail, the availability of resources. Is it available, yes or no? The capabilities to find the right resource, and also capacity. And when we look into that stack here presented by the EBU white paper about dynamic media facility, orchestration goes across all those layers, starting with infrastructure where you need to deploy it, your host platform, the container platform, then the media exchange layer, as we talked about it already, the media functions, and the actual user interface. So everything needs to go together under one big umbrella, what we call orchestration here, keeping in mind also security. And when you think about that's all we need to consider, unfortunately, in our eyes at least, you need a little more, because when you think about managing resources or technical resources, that whole life cycle, that's always tied to your service life cycle management, to what you do when you plan a production. You have different teams involved. You have not only technical resources. You need to book people. You need to book rooms, your cars, your hotels. Everything goes somehow together. And you cannot see the technical infrastructure management as something which is completely independent or not associated to what you do with the other teams. Because you have your infrastructure team to onboard your infrastructure. We talked about, or we have heard this in the last presentation. You need to know which is the infrastructure that I have that I can use. You need to schedule. That's a different team. You have MCR people, production teams, the NOC people. Then at the end of the day, you need to calculate costs. That's for procurement. And then don't forget about all the business layer and the service assurance teams. They also need to know about this. Your database inventory, the service desk ticketing systems, plant maintenance, super important. When you put something in plant maintenance, as a very simple example, you need to make the resource unavailable for somebody else to book it. If your server stack is in plant maintenance, you can't run a production. So that all needs to go together under a single umbrella or single source of truth. The key thing here when we talk about resource management orchestration, no more Excel sheets, no more pencils. You need to digitize workflows first in the operations. That's all, or that's the foundation before we can really execute on it. Again, on the left-hand side, you see our little life cycle of the media infrastructure, of the dynamic media infrastructure. The key thing, again, you need to plan and reserve resources ahead of time. Otherwise, if you wouldn't do that and you try it ad hoc, there is a risk that it fails. Planning things ahead of time means you want to have a guarantee when I plan it now that in a week or in a day or in a few hours, things can actually happen. To have that trust that things that are not running 24/7 will be available, will be readily configured. And the only way to do this, an orchestration system or that scheduling part of the orchestration system needs to know if the resources are available. It needs to know and find the resources that have the right capabilities and capacities to book the resources in time and to make sure the resources will be there when you need them. What is availability? It's pretty simple. It's either reserved or it's free. The interesting part there again, we talk about resources that don't even exist at the time of the booking. When I have a cloud resource and I need it in 2 weeks from now, how can I say it's available or not? There are certain dependencies on it, and we will look into that as well. Capabilities can be often technical capabilities. You have different resources from different vendors, from different manufacturers out there, and you need those. An orchestration system needs to know about those capabilities to make the right decisions and to reserve the right resource, but also the most effective resource. You don't want to book a UHD resource for an HD program because that's not efficient. Capacity can be many things. Often we talk about network capacity here, but also things like how many multi-flow pips do I need? That's also kind of capacity you need to track, be able to track. And here's a big challenge with the dynamic media infrastructure when we talk about scheduling, because those resources, first of all, we said they don't even exist at the time when you book them, but they have dependencies. Dependencies on compute, licensing, and bandwidth, network bandwidth. What are compute dependencies? That's rather simple. When you want to run some software or a microservice, you need to know as an orchestration system, do I have enough compute available in the future that I can run those? This is pretty simplified here. CPU, disk, memory. Predicting those compute resources depends on manufacturers. This is not like a very static number you can easily calculate, and that's a challenge we still need to solve as an industry. Can be the video content, can be the app configuration, can be many other factors that depend or have an influence on how much compute I need for a certain microservice. Licensing, very interesting topic. There are restrictions, or an orchestration system again needs to know, do I have enough compute? But you also need to know, do I have the licenses in the future available? Because I cannot run any kind of software when there is no license available. Either you have to buy them then upfront or it would fail. What's also what you see in the industry, the licensing models, and I guess everybody would agree, they are different per every vendor. They can be very complex. There's a mix of pay-as-you-go, subscription, perpetual, frame contracts. To manage those properly, it's a bit of a topic on its own, but as an orchestration system, again, the orchestrator as a minimum needs to be aware of if I have a license, and you can do it even better. You can also optimize license utilization. Another one, network dependencies, broad topic. There can be limitations or bottlenecks, certainly on the app configuration only, but also on the network interfaces on your host, on the network links between apps if you have a larger network, on ingress and egress. So many factors in the network that could be a potential bottleneck that you run into problems when you spin up all your media services. And even if when we solve all those technical problems, there are still a couple of them to be solved, people look more and more into the costs. That's the main reason why we do all that exercise on the dynamic media facility. So you want to optimize costs. That should also be part of everything you do with an orchestration system. There can be some basic rules to say you prefer on-prem deployment on your own tech stack across the cloud for 24/7 operations. All the peaks you will cover with some hyperscalers out there. And to do that efficiently, again, you also need to incorporate pricing models, the licensing models from the different vendors, of cloud vendors, tech vendors, to do the best calculation and to find the most efficient resource. What's important there, this is not static because pricing changes on the utilization. If you use certain vendors for only a few hours per month, pay as you go is the right model. If you use them for many, many hours, subscription model for a month or for a week could be the right one. And again, each and every vendor has a different approach on the licensing. That's something the industry is looking into. There are certain things we can do already, and we are working with some tech partners. But the more vendors you add, the more flexibility and the more variations you will see. Here is an example. You might see the logo. We are working with Grass Valley, just one of the vendors we are integrating with. What are we doing? Again, when you plan ahead of time, we can also calculate, or any other system can calculate the costs for the number of media services you need. And when you do this, like on a monthly basis, or depending on what the tech vendor comes up with, can also be a yearly base, you can make the right decision to say, I run certain media services, pay as you go, I need to buy a perpetual license, or I better do a subscription for a month or 3 months, whatever the vendors are offering. What we see here, and that's what we were experimenting and using it already, this is pretty good use case also to apply FinOps principles and using LLMs, AI. They can do usually a pretty good job on those kind of calculations. You throw in the numbers, you let a third party or an existing LLM think about it, and they come back with pretty good numbers on an estimate what you should do as an operator. And that's something we can then automatically apply again, because usually those APIs are available that you can turn things around to switch between pay-as-you-go and subscription models. And once more, what is key, you need to plan ahead of time. Otherwise, this will not work. A few things I want to show what we do with some vendors here on the show, what are the possibilities today, and a bit of best practices to make it work, because everything can be rather complex, but then on the same side, you should also be able to start now, not wait until everything has been solved. And there are, I guess, pragmatic approaches you can take to make this work and to start experimenting and using it also in practice. So what are we doing today? We are working with vendors like Grass Valley, with GBM, you might have heard it, Labo, with their home platform. Those are all software-based systems to make the dynamic media facility happen. What we are doing, we have scheduling capabilities. We allocate available capable resources. This is important, the scheduling part. Then we can spin up. We have heard that from Imagine in the other presentation. You can spin up and use orchestration tools, third-party tools to spin up EC2 instances, virtual machines, your Kubernetes stack. You start and stop your resources, your media applications. You configure them, you connect them, and you also calculate, track, and optimize costs. That all needs to go together. Also important here, that's an example from Labo home platforms where we calculate the required credits ahead of time, and only if you have, when I say credits, this is software credits, only if the system has enough credits in the future, an orchestration system can also confirm or commit to a production in the future and say, yes, I have enough resources because the resource goes along with my credits. What is important here, orchestration platforms, they need to calculate again How many credits does a certain resource need? There can be, again, a bit of complexity in there, number of inputs, outputs per media service, what kind of media service drives the number of credits you need in the future. But if you wouldn't do it, you run into a risk that you think you have the resource available, then you try to start it an hour before your event starts, and it will fail because there is no license or no credit available anymore. So it's mandatory to do this. How to make it work? When we talk to some of our tier 1 customers, they try to be, or flexibility is key, this is what they say, and they try to invent tons of different things. They try everything, spin it up, spin it down, all the variations you could ever think. But in reality, you don't need that many. We strongly recommend create a few templates, try those out, template your things, because you don't have productions the other day that you did not foresee at all. Those surprises in our market, usually they don't exist. Certainly you need some flexibility, but you can template a lot. You don't need all the flexibility out there. That helps already a lot. Use pre-built infrastructure. You can deploy infrastructure as code from scratch. Yeah, you can do it, but also think about what is the benefit. Sometimes it's just enough to have things started and stopped as an AWS EC2 instance. You don't have to do it from scratch all the time. You can do it, no doubt, but always think about, is it beneficial for me? When you repeat things and it's the same production every week, you don't have to destroy everything. You can just stop it and start it again, the very same production a week later. Here an important one. You need to talk to your procurement team how often they renew the licenses, because only then our system is able to also detect how many credits do I have in the future. If my procurement team buys new credits every week and I want to plan ahead of time 6 months, that will not fly, because then the orchestration system will say in 6 months from now there is no credit available, this will not work. So alignment between different teams, again, super important. Then a few more things on the challenges I had. What do we still need to solve? The challenges out there is what we do with our data miner platform. We can do a lot. We can manage the lifecycle, but there is a reality out there. You have a lot of subsystems you need to deal with. And some subsystems, they have their own sub-orchestration logic in there. Like a system like, once more, the example with Labo Home or Grass Valley M, there are also orchestration systems in itself. And that comes with a few challenges there. For example, one of those is here, very simplified. I want to book a production with a couple of multi-viewers, then a couple of video processing engines. You send some API commands to that subsystem from the vendor, and the vendor solutions then has all the intelligence to check if there is sufficient host capacity and deploys those on different hosts. As an orchestration solution, you don't know ahead of time if my multi-viewer 1 and 2 in that example that ended up on server A will end up on B or C or somewhere else. So that is tricky then to also predict the necessary compute and the network bandwidth on each and every server. We just don't know. And if you would only know, you can only find out at the time of execution. What else is important or still to be solved? How much compute does a certain video service need? Nobody knows, nobody can predict 100% ahead of time. There are two main solutions we are looking into. Either some vendors, they provide so-called manifest files, a pretty good estimate, which is a bit of a worst case calculation, saying when you do this configuration with those parameters, we need so much compute. We can work with that. Once we know the total compute you have available, and you know like the worst case compute, you can make the right calculation to see, do I have enough compute in the future to run those? That comes with a bit of a disadvantage. Usually the headroom is quite high and you become inefficient because you don't want to run or take the risk that you oversubscribe your compute. Another approach, which is a bit more work and needs more automation, you need to test things ahead of time. Let's say you plan a certain production with your template. The orchestrator, before you go into production, needs to deploy that production in a lab system or test system with the full configuration, read out the actual compute it needs, take that information, tear it down again, and 2 weeks later, we do the very same thing again. But doing this at the time of the booking, before you run the production, you have a much more accurate real-world situation. How much compute do I need? Because you have tested this before. What is important here again? You cannot do this manually. That would be a way too much work. You need to implement it, CI/CD type of operations to automate this part as well, the testing and the commitment or the results you get. As a conclusion, we have a minute left or so. You need to orchestrate, and orchestrate goes along, the way I use the word here, with scheduling capabilities. You must schedule ahead of time, otherwise there is a risk that when you try to spin up things and orchestrate things, that it will fail. Very important, it's not only about the technical resources. The resources have those dependencies, compute, licensing, network bandwidth limitations. You need to keep those in mind as well. And again, an important thing, resource management, dynamic resource management cannot stand on its own. You need to link everything with your service production, lifecycle management, service assurance workflows. That needs to go together. If they would run independent of each other, you would also probably fail, because then you don't have that single source of truth and things would be decoupled. And don't forget about why are we doing this? We want to be more efficient, save costs. So it's not only about getting the resources and having the guarantee and automating it, which is already a challenge. We also need to look into costs and do cost optimization, finding the best commercial model in a very dynamic way. You have heard about FinOps workflows a lot, I guess, also on the trade show here. This is becoming more and more important. So not only a technical challenge, but we also need to look into those models. And as everything is a bit complicated, sounds a bit complicated, we can start with simple solutions that bring immediate value. You don't have to wait until everything has been solved. And there are two use cases we see a lot from our customers. They have pretty simple problems. It's easy to turn things on in a dynamic environment. People often just turn everything on. The more you have, the better for a production. And then you have multiple productions at the same time using the same platform, and people are afraid to turn it off again because they just don't know what to turn off. There is a risk that you turn off the equipment in the other studio or the media services in the other studio. It's that simple. If you would tech it, if you automate it, that problem has been solved easily. And the other one is really also real-time or real-world example. People simply forget to turn it off. That happens. You run your production, you turn it on, you are stressed out, you shut it down, you leave, and it runs another 2 days or a week or a month. And then you get a call from your manager that the bill is slightly higher than expected. And using simple automation, that's really the key point I want to make. You solve two main problems in the industry. For sure, you could say, but what about the compute, the licensing, and all of that? What we say, build I call it a non-blocking environment here. Make sure you have enough licenses. You know pretty much what you need. Make sure you have enough compute available. Pretty much you can do it. And you test it ahead of time. Gives you a bit less flexibility, but solves some of the key problems already. And with that, I guess, yeah, we are close to the end of the show. Are there any questions? Thank you for still being here. You have one.
Thank you, Thomas. Really good presentation. Lots of good stuff to think about. So a question for you. On the back of all of those things you've said, what do you think the opportunities are for open specifications, open APIs, open SDKs? Which bit should we tackle first collectively? What do you think?
Well, first of all, everything needs to be available via API. The vendors we are dealing with, I would say the majority of data is available via API. Not everything, sometimes it's still a bit hidden or not as easy to access as it should be. There's always room for improvement. And then the second discussion is often on like standardized APIs or multi-vendor APIs, or do we need any other new standard? I guess reality out there is what we do with MXL, with more the open approach instead of waiting a couple of years until we've standardized everything, is the exact right thing. And everything needs to be open. What I would love to see is more initiatives really on the licensing and cost optimization. There you see vendors, and it's not blaming any vendor, but just as a fact, annual, because you have a frame contract, that's the reality out there. You sign a frame contract. Why would you expose data via API? But when you want to optimize it, yeah, you need to have data available also in a more digital way. Any other question? No more. Then thank you very much.